uh, definitions that'll become super easy over time because they'll be used the rest of the year. We're going to go over atomic theory, what it means, how he came up with it. We're going to make sure we understand what atoms are made of, where those parts are found, and what their charge is. And then eventually we're going to talk about Bohr model and some Lewis dot structures another day. So I'm sure you've heard this term, you kind of know what it is, and maybe you know entirely what it is, but atoms were, I don't want to say discovered, but kind of put into a unified theory here by Dalton. And his atomic theory says every element in the universe is made of tiny unique particles. Those are called atoms. They can't be subdivided. In other words, made into smaller parts. Later, they found it could be. So this wasn't right forever. However, the first part, every element's made of little unique particles called atoms, is true to this day. This is also still true. Atoms of the same element are exactly alike as far as properties and some of their little particles, and we'll explain that little difference in a little bit here. And then atoms of different elements can join to make molecules, still true to this day. So let's get into it. An atom, we said, is the simplest part of an element that retains all those properties. In other words, one atom of gold would act just like a brick of gold. One atom of oxygen, just like all the oxygen you're breathing in right now. We know you can find smaller parts like you see in this picture, but those do not act and have the same properties of the bigger element. How do we know all this? Well, like anything else, we've studied it, observed. We haven't observed this because you can't see something this small, but we have built scientific models and have mathematical formulas that show, yeah, this is, we might not be 100% right, but we've got it down pretty well, and I'll show you what I mean later about the not 100% right, but still knowing what they're talking about. All right, first part of the atom that we need to know is the nucleus. Just like a cell, it's the middle. It's the central core, it's the middle part. Here you can see it's circled, and there's some stuff in there. We'll tell you what those are in a minute. What those things are that are found in the nucleus are protons and neutrons. The charge means electricity. If you remember back to physics when you had that, you can have positive, negative, or neutral charges. And it's kind of easy to remember. Protons start with a P, and they have a positive charge. Neutrons start with a N, and they have a neutral charge. Both of those are found inside the nucleus, which you just have to remember. Protons, neutrons, nucleus, P, protons positive, N, neutrons neutral. And something that'll become important a bit, almost all the mass of an atom is here. You notice these red dots, they're around the nucleus. They basically weigh nothing. So all the mass for our purposes, like 99.999% of it, is found in the nucleus, and that's all we're going to care about later. So protons, we already said, positive, Pp, found in the nucleus. And they are what determines what the element is. So if we look down here, this picture, it says has 8 protons. That makes it oxygen. If it had 9, it would be fluorine. It wouldn't be oxygen. So you can't change the number of protons and keep the same kind of atom, because this is what defines an atom. Number of protons determines what atom you have. Because it's so important and it determines what kind of atom we have, we call it the atomic number. So the atomic number is just another way of saying the number of protons in an element. In a neutral element, protons equal the number of electrons. Unless told differently, this number 8 here, this atomic number in this green periodic tile, tells us the number of protons, 8, but also the number of electrons. Later we'll learn how to show what happens when you lose or gain electrons, but right now we're going to just think of it as whatever that atomic number is right here in this picture, 8, tells us protons and electrons. Neutrons, they're a little different. We do know they're neutral with the N, they're found in the nucleus, but their number actually is different among atoms of the same element. We look at this picture. All 3 of these pictures here are carbon. But if you look in the yellow part, it says carbon 12, carbon 13, carbon 14. I might X out of here so I can draw and circle some things here for you. Now the key here is, look at the protons. 6, 6, 6. We said those can't change because if they do, you don't have carbon anymore. But at the bottom, this first picture has 6 neutrons This one has 7. This one has 8. That's where these numbers come in. We'll learn in a second that's called the atomic mass, but it's the number of protons plus neutrons. 6 plus 6 gets 12. In this, we had 6 protons and 7 neutrons, so it's called carbon 13. 6 plus 7 is 13. 6 protons plus 8 neutrons here is carbon 14. Gets back to the big picture for us. Oops, I almost skipped here. When we do have a different number of neutrons, it's called an isotope, another vocab word we're going to get familiar with and need to know. So again, protons never change. It's all carbon. They're called isotopes because what does change is the neutrons. Remember, neutrons don't have a charge. They're neutral, so it doesn't affect anything except the mass of that atom. I said this, but now here it's in writing. Atomic mass, protons plus neutrons, and all we care about is what's in that nucleus, those protons and neutrons. If we label them, it's going to be an AMU, an atomic mass unit, but really I'm happy if you just know what everything counts as 1. If you have 1 proton and 1 neutron, each of those counts as a 1, so 1 plus 1 would be 2. So you simply find out how many protons and neutrons are in the nucleus, add them up, and that's your atomic mass. The one thing we didn't go into detail in that first picture were electrons. Well, they're the other particle we need to know, and they're negatively charged, the only thing we have left. They basically don't have a mass. They're so small, so we don't count them. And they go ridiculously fast and unpredictable. So we can't say for sure where they're at, but we say they're in different energy levels. So they're in some region that's close to the nucleus. If there's too many, they move to an outer level, and eventually we'll tell you how many each of those levels can hold. But the further away they go, the more energy they have. So if you're in the same energy level around the nucleus, you're basically the same distance. You're going slightly different. It might be ridiculously small number off, but for our purposes, you're the same distance. We already said the further you go away from the nucleus, the more energy you have. And these numbers today won't be all that important, but eventually they're going to be hugely important. Each level, energy level around the nucleus can only hold so many electrons. So the closest energy level, look at this picture here. The closest energy level, it's a little circle here, has 2 only. Well, this picture only has 2, this picture 2. Every picture only has 2 in that first level, because that's all it can hold. If you have more than 2 electrons, you have to move to that next level, which can hold up to 8. Well, this only has 1. Okay, that's less than 8. You're good. 2 on the first level, 1 on the next. Here, this last picture, neon, we have 2 on the first level, these 2, and 8 on the second. So if we were to add an electron, it would have to go out to the third level, which can also hold 8. We'll do lots of practice with these eventually. Go ahead, pause here while you put this into your notes. Here's a video. I'm going to kind of skip ahead so you can see the pictures rather than listen to everything. But if you Google protons, what's inside an atom, you can watch this on your own. Neutrons. And really, that's the big thing right there. That's really what I wanted you to see. I want you to watch the video, but you are a little behind. If you get the notes, you'll be all right. Here's the center. That's called the nucleus. Protons, neutrons. Protons are the reddish color here, the neutrons pink. This first energy level has 2 electrons. If we had more, we'd go out. So let's look at some of our vocab. Here's the nucleus. We have 2 protons, 2 neutrons. Add that up. That's 4. That's our atomic mass. Just practice what we know. All right. Big summary. This is the page. If you're confused, pause it, study it, look at it. Protons, positive charge in the nucleus. Neutrons, neutral charge, N and N, P and P, no charge in the nucleus. Electrons, negative charge around the nucleus, in electron clouds or energy levels, whatever you want to think of them as. We said the nucleus is super small. Dense means stuff's packed together and it's right in the middle of the atom. And each element has a unique number of protons and electrons. How do we know that number? The atomic number in the periodic table tells us. Press pause and practice these. Think of the answer and then I'll give it to you. What charge do protons have? Pause it. Remember, P and P, protons are positive. Electrons are negative. You just have to remember that one. Neutrons, N and N. Neutrons are neutral. What particles are here in the middle of the nucleus? Press pause while you think. We said protons and neutrons are in the middle, and electrons are outside of that. Press pause and think if you can label all these. All right, I'm going to start with C. C is the circle surrounding everything's here in the middle. That's our nucleus. Inside the nucleus, we have positive stuff. Well, that positive is P, protons. We have these white ones that have nothing on them, so B would be neutrons. E is negative stuff, that's electrons, and D is our electron shells or energy levels. Press pause on this screen while you add this to your note guide. You're not going to have a science song break, but if you want, you can Google search that if you want to hear it. All right, so again, reviewing important stuff that we're going to practice soon. Atomic numbers. In this case, it's 47. These numbers will be given to you, or the number of protons and neutrons will, and you can figure it out. But that's our key. Atomic number is the number of protons and also electrons, unless we tell you differently. So silver has 47 protons and 47 electrons. Oxygen here has an atomic number of 8, so that's the number of protons and electrons. You also see things like this, where you have two different numbers. In some books, videos, whatever, we'll have these numbers flipped, and the 6 will be on top and the 12 on the bottom. The order doesn't matter. Remember, if atomic number is number of protons, it always is going to be smaller than the mass number, or equal, because the mass number is protons plus neutrons. So this means we have 6 protons. This number means we have 12 protons plus neutrons. So to figure out the number of neutrons, subtract these. 12 minus 6 would mean we have 6 neutrons, and this number already tells us 6 protons. Again, if you're confused, don't worry, we'll practice a lot. In this picture, 1, 2, 3, 4, there's 5 red particles. Okay, that's our atomic number because there's 5 protons. 1, 2, 3, 4, 5 blue, so our mass number would be everything combined. 5 plus 5, mass number 10, atomic number 5, because that's just protons. The atomic number, we're not going to mention the Z, like that's not important, but the atomic number is protons plus protons, period. And also electrons, we'll get to that later. The mass number, protons plus neutrons. We don't care about electrons for that. Press pause while you add this into your notes. All right, isotopes. We mentioned it earlier, barely. Isotopes is the fancy way of saying you have different numbers of neutrons. So in this picture here, we got 2 numbers, 1 and 1. Well, the smaller number, in this case they're the same, is the number of protons. The bigger number, in this case equal, is the number of protons plus neutrons. So this isotope of hydrogen doesn't have any neutrons. If we look at this picture, now we've changed. This number is still 1. That tells us the number of protons. That can't change. This number is 2 because now we have 1 proton and 1 neutron. 1 plus 1 is 2. Over here, we have a mass number of 3 because we have that 1 proton. Now we have 2 neutrons. It's all the same atom. It acts the same because neutrons are neutral, but it weighs different because of the number of neutrons it has. Another example, pause and look if you're still confused. We'll practice a lot though. You can read through this again. It's going to show you how to figure it out, but we will practice plenty in the future on determining mass numbers and atomic numbers. Press pause while you add this to your notes. Press pause while you think. So earlier we said kind of, but they don't have to be because they can have different numbers of neutrons. They act the same. They have the same number of protons and electrons, but neutrons can be different. Which thing in this picture, proton, neutron, electron, or nucleus, determines what element you have? I hope you said protons because that is what determines it and can't change without changing the element. In isotopes, we said they have the same number of protons, but what is different? I hope we know it's neutrons because they're neutral and they don't change anything. Mass number. Mass number is protons plus neutrons. And that should be it.